Good morning to all.
Good morning,
Good
sir.
morning, sir.
Good morning, sir.
Good morning, sir.
Good morning. What was the last thing we did in the previous class?
Star delta.
Star delta.
Dielectrics, star delta.
Infinite series is left.
Steady state, find the charge on the two capacitors. Steady state, find the charge on the two capacitors.
So star delta can only be applied if all the three are same, right? Like all three are resistors or all three are capacitors.
You are asking me directly the hint for this problem. Write down the question. In steady state, find the charge on both the capacitors. And underline the word steady state. You said steady state, there will be no current in this branch with the capacitor. Do you agree with that?
Yes, sir.
Sir, can you mark for 1 minute?
Okay, okay. I'm good. In steady state, there will be no current passing through the branches with the capacitor. So technically, you can redraw this circuit this way. This will be 20 ohms. This and this are in series. There's no current going in this branch. Here, these both are in series, that is in parallel with this. 20 and 10 are in parallel. 20 into 10 divided by 20 plus 3. 200, am I right?
20 plus 10, right?
20 plus 10.
20 plus 10.
20 by
20 by 30 is 20 by 3. This is 20 by 3. This will be 10 ohms. This will be 20 by 3.
20.
This will be 20 ohms. Here, he is not asking you for the equivalent resistance for you to apply star delta. He gave you the battery voltage. He gave you the battery voltage. He wants the potential difference across this. If I get the potential difference across this, will I get the potential difference across this?
Yes, sir.
If I get the potential difference across this, I'll get the potential difference across this. So I need the current in this branch. I don't want R equivalent. Don't jump to conclusions and apply Kirchhoff's law. Don't jump to conclusions and apply star delta. Kirchhoff's law will be much safer. You need only the current in this branch. Star delta, if you want the equivalent resistance, it works out. Here, I have only two equations and two variables. Kirchhoff's law will be pretty safe. Capital I current goes into this, small I, capital I minus small I. Capital I minus small I, small I. This minus this is 2I minus capital I. This minus this is 2I minus capital I. How many variables do you have? Two variables, capital I and small I. How many equations do you have? Two equations. I'll apply KVL to this loop and this loop. Why are you not applying to this loop?
Already got I minus it.
You will get the same equation. Right? Opposite to the direction of current, 20 by 3 into I minus I. In the direction of current, 20I minus of 10 into 2I minus I is 0. When you apply KVL to the lower loop, you are touching the negative terminal first. 100 minus 20 by 3 into I minus I minus 20I is 0. Two equations, two variables. Eliminate capital I, find small I. 20 into I is the potential difference across this, which will be the potential difference across this. Once I know the potential difference, getting the capacitor, getting the charge on it will not be difficult.
Done, sir.
So 1 minute. So is the earlier smaller 25, 75 or 24?
What are the others getting? Molai, I don't have the value with me. Small I, how much did you say?
75 or 24?
I don't think. I vaguely remember the answer. 35 by 12, maybe. I'm not sure. Are the others getting that?
So 25 by 8.
Others didn't do the simplification.
Sir, 25 by 8.
No. Infinite series. What do you mean by this infinite series? It is a game of numbers. You stop at one point. You want the equivalent resistance across AB. This is 1 ohm, this is 2 ohms, this is 1 ohm, 2 ohm, 1 ohm, 2 ohm. Each of this is a building block. After every block, the equivalent resistance will be the same. This is infinite series. Infinite series definition is number of blocks don't make a difference. Number of blocks do not make a difference. Whether I have 3, whether I have 4, whether I have 10, whether I have infinity. Every time I remove one block, I get the same answer. How they put it as definition is whether you find the equivalent resistance across A dash, B dash or AB, it will be the same. equivalent resistance between A dash, B dash or AB, it will be the same. So number of blocks don't make a difference. Hence I can take it up to infinity. You mean to say, if I stop here, I will get R equivalent. Here also I will get R equivalent. The same answer will repeat after every building block. The same answer will repeat after every building block. These both are in parallel. 2 times R equivalent by 2 plus R equivalent plus 1. This is in series with 1. Should again give me R equivalent. This is what you are telling me. After every building block, the answer will be repeated. So here I stop, I get R equivalent. Here also I will get R. This will be 2 times R equivalent plus 2 plus R equivalent upon 2 plus R equivalent is equal to R equivalent. I took the LCM. 3 times R equivalent plus 2 is 2 times R equivalent plus R equivalent whole square. R equivalent whole square minus R equivalent minus 2 is 0. Keep an eye on the simplification. Right? What will be the solutions for R equivalent?
Two and minus one.
2.
2 and minus 1. Eliminate minus 1. The answer will be 2. What were you telling me? Whether I stop here, whether I stop here, whether I stop here, whether I stop here, I'll get the same answer. The repetition of the answer is the catch in infinite series. Let me stop here. If you are telling me the answer is 2, 2 and 2 are in parallel. Equivalent resistance is 1. 1 and 1 are in series. Equivalent resistance is 2. Now again 2. 2 and 2 are in parallel. Equivalent resistance is 1. 1 and 1 are in series. Equivalent resistance is 2. After every building block, whether you stop here, you keep getting the same answer. Whole of the game is about recognizing this building block, this building block, this building block. After any building block, the answer will be the same. Hence, it's an infinite series. You can take up to infinity or you can make it finite, makes no difference for us. It will turn out to be the same. Now, in this category, they have Krotov has given 2 typical problems. You will not have another problem like that. Take it down till here, we'll deal with those 2 problems. What if this resistance is R1, this resistance is R2, this is K times R1, K times R2, K square times R1, K square times R2, so on and so forth. Every building block, the value is increasing by K. Every building block, the value is increasing by K. So indirectly, they are giving you a hint that the equivalent resistance also will increase by K. This is R equivalent, it will be K times R equivalent, K square times R equivalent, K cube times R equivalent, so on and so forth.
Yes, sir.
So if you are taking
So can
R
you try?
equivalent here, it will be K times R equivalent here, K square times R equivalent here, so on and so forth. So you mean to say R2 into K times R equivalent upon R2 plus K times R equivalent plus R1 is equal to R equivalent. You are asking me to find out R equivalent in this. Every K can even be a fraction, it can be a number. K could be half, K could be 2, K could be anything. But every building block should increase by the same fraction. If you take K1 here, K2 here, and so, then the symmetry is lost. This will be applicable only if it is symmetric. Is there any proof for this? This is slightly beyond your scope. He is just playing with certain rule of symmetry.
So this will be like an infinite GP that is tending to 0, R less than 1.
K less than 1.
So in this case, how did you equate it to R equivalent? Since the R equivalent after each block is not the same, we should equate it to something like K times or K square times R equivalent, right?
That's what you have done. If here it is K times R equivalent, this is R equivalent. Every building block is increasing by K. So X, K times X, K square times X, K cube times X, so on and so forth.
So do we have to simplify?
No. Same problem, Croto put it in a slightly different way as well. Can I rub the board?
Yes, sir.
Same problem. The factor is decreasing by a common factor. How he put it as infinite triangles, equilateral triangles. Infinite equilateral triangles. And rho is the resistance per unit length. Resistance per unit length. This will be rho L. This will be rho L. This will be rho L. So what will this resistance be? Rho L by 2, rho L by 2, rho L by 2.
Yes.
Rho L by 4, rho L by 4, rho L by 4. So it is every next building block is decreasing by half resistance. Right? So if I stop at this building block, Observe this. If I tell you this is R equivalent, this is R equivalent by 2. This is rho L by 2, this is rho L by 2, rho L by 2, rho L by 2 and rho. Rho L by 2 and rho L by 2 are in series, that is in parallel with R equivalent by 2, that is in series with these both, that is in parallel with this, equated to R equivalent. Right? You stop here, you got R equivalent by 2, this will be R equivalent. Or if you call this R equivalent, this will be 2 times R equivalent, because every time you are going one triangle inside, it is decreasing by 2, other half. So this is R equivalent by 2. If I would have stopped here, what would I have written? R equivalent by 4. If I had have stopped here, what will I write? R equivalent by 8, R equivalent by 16. Now here students get a genuine doubt. Why did you put R equivalent only across these two terminals and why not across these two terminals?
Symmetry.
Previous cases, you could make out where you had to place R equivalent. Here, why not along this? Observe this. Very first rules of symmetry when we said, if the current comes in, if this is I1 and this is I2, I should get back I1 and I2 here. So this will be disconnected this way. This will be disconnected this way. Here it will be disconnected. So that whole of I2 goes into this. Whatever current splits here should add up here. So the R equivalent will come across these two terminals and this point will be disconnected.
So I'm having a doubt in this from the start. Is it not possible that I2 gets added up a bit from the lower part joining and I1 gets reduced like that?
Across this line, if you keep a mirror, the left and right looks identical.
Yes, sir.
So if this is I1, this must be I1. This is
Got
I2,
it.
this must be I2.
Got it.
Sir, could you explain how you took R equivalent and R equivalent by 2 in this case again?
Every building block, the resistance is decreasing by half.
Yes, sir.
In the previous example, what you wrote K, here is 1 by 2. So if I stop here and I get R equivalent, I stop here, I will get R equivalent by 2. Here I'll get R equivalent by 4. Here I get R equivalent by 8. Here I get R equivalent by 6. I'm coming from inside. From the smallest triangle, when I come here, I'll get R equivalent by 16. Here I'll get R equivalent by 8, R equivalent by 4, R equivalent by 2, R equivalent.
Got it, sir.
Sir, how did you get it is half?
Equilateral triangle, no, yaar. Each length is decreasing. Rho is given as resistance per unit length.
Right.
Length of the triangle is decreasing by 2. So resistance is also decreasing by 2.
Right, sir. Thank you.
So how do you make the lower diagram? I'm getting confused a bit on.
Across this, it is R equivalent by 2. Across this, it will be R equivalent. So in the infinite series, when you are coming from there, you remove all the infinite series and you put R equivalent by 2.
Understood, sir. I got clear.
JEE technically till date never asked questions on infinite series, but in your test series they keep asking questions on. Right. There is one infinite grid problem given in Irdo based on resistors, which I will deal with in the chapter current electricity. Now we deal with one very strange controversy in electrostatics. Before we go to spherical and cylindrical capacitors, right? One typical problem from this is C, this is C naught, this is A and B. A typical problem, you will not get another problem like this, but it's a good one. When the switch is thrown from A to B, they're asking you what is the work done by the battery. When S is thrown from A to B, find work done by battery.
Can we try once?
Yes. Think carefully and try, don't be mad.
So 0.
No. Are you trying the problem?
Yes, sir.
Yes.
Mhm. Somebody is asking, do we have the concept of negative resistance? Negative resistance comes in semiconducting devices, not in linear circuits. Now listen, this problem is slightly tricky. When you're able to visualize, job becomes easy. Have a look at this. Can I claim these both to be in parallel, that is in series with this? C and C naught. C and C naught. Positive, negative. Whether I put here positive, negative, negative, positive, negative, positive. C and C naught are in parallel, that is in series with C. C and C naught are in parallel, that is in series with C. Right? Now, what is the final situation? Can you see this part of the board? Can you see till here? Till
Yes.
here it is visible. What will be the final situation?
Battery
This,
will be reversed just.
this C naught this is V, this is A and B, this is C, C naught and C. Now this will be positive, negative. Polarities did not change. By the way, have a look at it. This. If I take the charge on this to be Q and Q naught, charge on this will be Q plus Q naught. Positive, negative, positive, negative. Charge on this is Q. Charge on this is Q naught. What will be the charge on this? Q plus Q naught. Do you agree with that?
Yes, sir.
Right? So because these both are in parallel, the charge splits. It comes as this and it will split into Q naught and Q here. Now that I have thrown the switch from A to B, what will be the charge on this? Q.
You know.
What will be the charge on this? Q naught. What will be the charge on this? Q plus Q. See if you are convinced. Now C and C naught are in parallel. So
Yes.
Q plus Q naught, and this will have Q plus Q naught charge on the capacitor. That means this capacitor will become series. This C naught is coming here. This capacitor will be here, and this C naught will come here. So far, so good, all of you. Yes or no?
Yes, sir.
Yes, sir.
Recollect when we dealt with charge distribution, we said whenever you close a switch, first a capacitor will look in the neighborhood. If it gets help from the neighborhood, it will first take help from the neighborhood. If it doesn't get help from the neighborhood, then it goes for help from the battery. Right? Now consider this. When you threw the switch from here to here, what all changes happened? Q plus Q naught came down to Q with the same polarity. First point. Q plus Q naught came down to Q with the same polarity. First point. Agreed?
Yes, sir.
This capacitor remained Q naught, but the polarity is reversed. Initially, the lower plate was negative. Now the lower plate is positive. This capacitor's polarity reversed, but the value is the same. Second point. This capacitor's polarity is the same, but the value increases to Q plus Q naught. Polarity of the right extreme and the left extreme didn't change, but the values changed. Middle capacitor polarity reversed, but the value remained the same. So first of all, to reverse this polarity, I should get Q naught charge to nullify this capacitance or nullify the charge on this. Do you agree with that?
Yes, sir.
So first thing that will happen is when I threw the switch to this, I have positive and negative. I had positive and negative, negative and positive. Q plus Q naught, may this Q naught will come and nullify this charge. C naught, C and C. This Q naught, this capacitor should leave Q naught charge, and this capacitor needs Q naught charge with opposite polarity to nullify this.
Yes, sir.
So when it nullifies, what do you get? You will get one C naught this way and one C this way, and this is C. This was negative, positive. I'm left with Q, no charge on this, and this is negative, positive. I am left with Q here. Q naught came and nullified this charge. Now from here, for me to go till here, what happens? This is not charged. This came down to its final state. Now this capacitor needs to be charged to Q naught. Do you have any charge in the neighborhood just as this Q naught came to the rescue?
So can minus Q naught go from C? The left one. Now minus Q naught will go, so it will reach C naught to
I
make it
need
minus.
additional charge on this capacitor. It was Q. It should rise to Q plus Q naught. I need additional charge on this. It cannot leave charge. It will pull charge. Right? I want additional charge on this capacitor. It should rise to Q naught. This capacitor is nullified and this capacitor is to its optimum capacity. Now I don't have any charge available in the neighborhood. I will ask help from the battery. It should push Q naught amount of charge, which will come and settle here by induction induced, plus Q naught will come here, and this will rise to Q plus Q naught. This will rise to Q plus Q naught. How does the charge know that it has to flow only this way and it doesn't go to the other side? Flow of charge is governed by the potential difference. So the potential difference will govern the flow of charge. This Q naught will come over in this particular path. That means battery pushed how much charge, work done by the battery will be V into Q naught. If you can tell me Q naught, my job is done. Because once Q naught is pushed, this is charged to Q naught with this polarity. This rises from Q to Q plus Q naught. Q naught comes back into this particular battery. Can I calculate the value of Q naught? Comfortably, have a look at it. C and C naught are in parallel. C plus C naught into C divided by 2C plus C naught plus C should be equal to C equivalent. C equivalent into V is Q plus Q naught. C equivalent into V is Q plus Q naught. This is my first equation. Second equation, Q by C is Q naught by C. Q by C is Q naught by C. Will I get Q naught from here, which I can substitute here?
How to write the first equation?
C equivalent into V. I found out the C equivalent
Right.
into V will be equal to the total charge initially pushed by the battery That is Q plus Q naught.
Yes.
A very typical problem from Redrawing. Once again, you don't find another problem like this.
The second equation.
Potential difference across this and this is equal. Q by C.
Right.
क्या पूछ रहे हो यार?
Sorry.
By C, how did I equate to Q naught by C naught rather? Q naught by C naught. Q naught by C naught is equal to Q by C.
Initially, you took two variables, right? Q naught and Q.
Right.
So can negative charge flow from a positive terminal?
And negative charge flow from a positive terminal. That capacitor is leaving charge or is the battery pushing charge?
So like I was saying for the second last diagram in the stage, we needed a Q naught for C naught, right?
Right.
Which we got from the cell. But I am saying that is it possible
Cell is
that
pushing that
yes, sir,
positive.
yes. But I am saying that is it possible that the C naught which was on the left of it, the C which was on the C which was on the left of it, it will give out minus Q naught charge. So now the charge will become Q
Cannot
plus
it
Q naught.
needs. See, how will it give out charge when it needs? Originally it had Q. Now it should acquire Q naught. So minus Q naught should come here.
Okay.
Or plus Q naught should leave. I need additional minus Q naught. It is as good as telling you plus Q naught will leave. But how will plus Q naught leave? There should be some mechanism for it to leave, right?
That is not possible.
Battery pushes that Q naught through this.
Understood.
Sir, sir, can you explain that same potential? How did you get?
Same potential.
Second equation, we derived that by telling. Okay, sir.
Q by C is Q naught by C naught.
Sir, in C equivalent, why did you add this C after the multiplication part?
C and C naught are in parallel. That is in series with C. Sorry, I think it's right. C plus C naught into C divided. Again, I don't. This is C. Is right. C and C naught are in parallel. Equivalent capacitance is C plus C naught.
Yes, sir.
That is in series with C. That into C divided by C plus C naught plus C is C. All of you make that change. I by chance added one more C, not required. C plus C naught is C equivalent of these two, that is in series with C. So that into C divided by sum of all.
So voltage is given in the question, right?
Yeah, V is given.
So V square C square upon 2 C plus C naught.
Think here, I don't know the answer. Q naught calculate and substitute in that. V into Q naught will be the answer. Is this clear to all?
Yes, sir.
We need to deal with one very strange controversy. Series last solved example is a conceptual blunder. Why it happened so, how it happened so, everything will be explained in detail. Please concentrate. First of all, when you introduce a dielectric in between, epsilon r, this is Q, this is minus Q, Q naught and Q. I will have induced a negative charge and positive charge. Sigma I with a negative sign, sigma I with a positive sign. This also takes sigma naught minus sigma. If this were a metal, sigma I will be equal to sigma naught. Do you agree with that?
Yes.
Yes, sir.
Right? So now what happens is, this is an external field, this is the induced field. E naught minus E induced will be equal to E naught by epsilon r. Net field inside the dielectric is E naught by epsilon r. Induced charges. External field minus the induced field will be the net field inside. I know the net field inside to be E naught by epsilon r. Yes or no?
Yes, sir.
Yes, sir.
E induced is E naught into 1 minus 1 by epsilon r. E naught is sigma naught by epsilon naught. 1 minus 1 by epsilon r. This is sigma I by epsilon naught. E induced is sigma I by epsilon naught. E naught is sigma naught by epsilon naught. Sigma I is sigma naught into 1 minus 1 by epsilon naught. If the area of the plates are the same, I can write Q induced is Q naught into 1 minus 1 by epsilon r. Are we expected to remember this? Yes. The quantity of induced charge will depend on the nature of the dielectric material. Interestingly, for a metal, you know Q induced is equal to Q naught. So 1 minus 1 by epsilon r is 1. 1 by epsilon r is 0. Epsilon r is infinity. For a metal, epsilon r is infinity. Yes. Then for a capacitor, why don't you use a metal in between? Use a metal like this, surrounding this. Instead of placing a dielectric material, if you use a metal, its
Or, sir,
capacity according to you is epsilon r times C naught. Now epsilon r is infinity. So its capacity will become infinity. You're right. Keep giving charge, it will keep taking charge. Any amount of charge you give will be going into the ground. But my purpose is not served. Then why don't you use a metal in between two parallel plate capacitors? My purpose is to store energy here. Field is becoming zero. I'm not able to store energy. Jitna energy of zero, it's going into the ground. You keep giving, it keeps taking. Capacity will actually become infinity, but it doesn't store. My requirement is not just taking energy. My requirement is storing energy. So theoretically, if I put a metal in between, capacity will become infinite. We have no issue with that. But our purpose is not served.
so can we claim that capacitance of capacity of a piece of wire is also infinity?
Anytime you can connect it to the ground, the key you keep giving charge, it keeps taking charge. So sigma I is sigma naught into 1 minus 1 by epsilon r, something that you people should remember. Sigma I is sigma naught into 1 minus 1 by epsilon r. Then starts the trouble for us. Take it down till here. This is induced charges on the surface of a dielectric. Induced charges on the surface of a dielectric.
So can you please show the first equation? How did you get it?
External field minus the induced field is the net field inside the dielectric. External field is E naught. Induced field is field due to the induced charges. Net field is E naught by epsilon r.
Yes, sir. Got it. So in that previous question, if we assume the polarity is wrong, so we'll get the wrong answer.
How will you assume the polarity is wrong? Direction of the battery is fixed in my यार battery का direction दे दिया है.
Understood.
Can I rub the board?
Yes, sir.
Sigma I is sigma naught into 1 minus 1 by epsilon r, something that you people will have to remember. Don't forget this. Now, whole of the controversy started with something called stress in a dielectric. Originally, problem picked up from the 4-author Russian book. Calculation of stress, we didn't have a trouble. We didn't have stress while calculating the stress. Stress in a dielectric. Stress in a dielectric. By the way, how do you define stress? Definition of stress.
Force per unit.
Force per unit.
Area.
Ironically is wrong. Think again. That is what whole of this controversy will be based on. Stress is not force per unit area. बोलो.
Sir, electrostatic force by area.
नहीं. No cheap tricks.
Can I repeat the question?
Stress का definition. Somebody is typing strain into modular systems. इसको hang him upside down once. A631 upside down.
So the pressure.
This is restoring force per unit area of cross section. It is very important that you realize that it is restoring force, not the force applied. क्या बोल रहे हो यार? Both of them will be the same. No यार, I am pulling with a force of F. Restoring force will be F. Not always. Not always. This is M1, this is M2. I am pulling with a force of F. Radius is given as R. What will be the stress? Is it F by pi R square? Wrong. It will be tension by pi R square. Stress is defined as the restoring force per unit area of cross section, not the force per unit area of cross section. See the difference? Force I applied is F, but the force is not equal to the tension in the string. In this, the stress will be restoring force. I'll put it in much more simpler language. Two people are holding the string and pulling with a force of 100 Newton and 100 Newton. Two people are holding the string and pulling with 100 Newton and 100 Newton. Net force on the string is 0. Do you agree with that?
Yes, sir.
Yes, sir.
Yes, sir.
Net force on the string is
Zero.
0. Shall I call the stress to be 0?
No, no, sir.
It is not 0. Right? I am holding two ends of the string and I am pulling with 100 and 100 Newton. Say 10 and 10 Newton. I am pulling with 10 and 10 Newton. Net force is 0. Tension is not 0. Stress is not 0. It has stress. It has stress in it. If I apply greater force, the string will break. Right? So it is the tension in that string which is the restoring force. It's so very important to realize that it is restoring force and not the force applied. University physics gave this as the first reasoning question in elasticity. Is stress a consequence of strain or strain a consequence of stress?
Strain of function.
Is stress a consequence of strain or strain a consequence of stress?
The independent.
You have only two options. Either stress is a consequence of strain or strain is a consequence of stress.
Strain is a consequence of stress.
So you people yet feel because I apply a force, there is a change in dimension. You're right till there, but the force you applied is not stress. You are under the feeling that I applied a force, so there is change in dimension. I am okay with it, but the force you applied is not the stress. What is stress? Restoring force. When will restoring force come into picture? When there is a change in dimension. So stress is a consequence of strain. Stress is a consequence of strain. Restoring force comes into picture when strain is applied. Restoring force comes into picture when there is strain. So stress is a consequence of strain. Be crystal clear about it. Force you applied undoubtedly will create the strain, but the force you applied is not stress. Restoring force is stress, which will try to bring back the body to its original shape, size, and volume. Is this very clear to all?
Yes.
Fundamental concept of stress and strain. Now we use that in electrostatics to define stress in a dielectric. First, take this term.
Done, sir.
Whenever I ask stress, You will try to calculate the tension in that string divided by area of cross section. Fair enough? Now stress in a dielectric. You have positive charge here, you have negative charge here, and this is a dielectric. Epsilon naught. This is sigma naught minus sigma naught. I have induced a negative charge, positive charge. Sigma I which is negative, sigma I which is positive. Now I want the stress in the dielectric. Net force on the dielectric is 0 because this positive charge will pull the dielectric to the left. They show that this positive charge will pull it to the left. This negative charge will push it to the left. This positive charge will pull it to the right. Same three forces are acting even on the right side of the dielectric. So net force on the dielectric is 0. Remember that. Net force on dielectric is 0. But not tension in the dielectric. Tension in the dielectric is not 0. You're pulling one end of the rope with 100 Newton. Other side you're pulling other end of the rope with 100 Newton. Right? What is the tension in the rope?
200 Newton.
100 Newton. I am pulling with 100, string will pull me with 100. Every action has an equal and opposite reaction. I am pulling with 100 Newton. String will pull me with
100.
100 Newton. So tension in the string is
100.
100. So if you can calculate force on one side of the dielectric, you will get the tension in the dielectric. Is everybody convinced?
Yes,
Yes,
sir.
sir.
Net force you calculate, it will become 0. Force on the negative and positive charge are equal and opposite. So you are trying to calculate the tension in this particular dielectric. How do I get the tension in the dielectric? Restoring force in the dielectric will be force on this induced charge due to sigma naught. Sigma naught by 2 epsilon naught into sigma A. See if you are convinced. This positive plate will give me a field of sigma naught by 2 epsilon naught. That into charge is sigma into A. Right? Now this negative charge will exert the same force on it. Can I multiply this with 2? Minus sigma I by 2 epsilon naught into sigma I. See if you are convinced. Sigma naught by 2 epsilon naught is the field because of this positive charge. That into sigma IA. That into sigma IA. 2 times because of the negative charge. Now this positive charge will exert a field of sigma I by 2 epsilon naught into the charge sigma IA. Net force on one side of the dielectric I calculated. Net force on one side of the dielectric I calculated. Agreed?
So won't you add field and forces due to sigma naught and minus sigma naught on sigma I, the positive one?
I am calculating force on this side. Why will I calculate the force on this side? I am calculating force on one side of the dielectric.
So won't it be force on one side plus force on the other side?
Come again.
Won't it be force on one side plus force on the other side?
So net force on the dielectric लेना चाहते हो आप?
Yes. Oh, okay, that's 0.
Net force on the dielectric is 0. It will be a blunder if you take that for stress.
And
I want the tension in the string. Tension will be force on one side. Tension will be force on one side. So I calculated force on one side due to 1, 2, and 3 charges.
Got it.
Two sigma naught by 2 epsilon naught. Sigma is sigma naught into 1 minus 1 by epsilon r. We just now derived this. sigma naught square into 1 minus 1 by epsilon r whole square a by 2 epsilon naught. All I did is substituted sigma s sigma naught into 1 minus 1 by epsilon r. Sigma naught square a by 2 epsilon naught 1 minus 1 by epsilon r. From here I got this common. I have 2 minus 1 plus 1 by epsilon r. Sigma naught square a by 2 epsilon naught 1 minus 1 by epsilon r. This is 1 plus 1 by epsilon r. Q square by 2a epsilon naught. Sigma naught I substituted as Q by a. Q square by a square and a. A plus b into a minus b. Epsilon r square minus 1 by epsilon r square is the tension on one side of the tension in the dielectric material. Tension will give me the restoring force. How do I get the stress? T by a is q square by 2a square epsilon naught epsilon r square minus 1 by epsilon r square is the stress in the dielectric. Nobody has a controversy till here. The 4-author Russian book gave this problem and this is the solution proposed by them. Till here there is no controversy. Till here everybody is clear that you should take restoring force. What is restoring force? Tension in the dielectric. How do I get tension in the dielectric? Calculate the force on one side. I am pulling the rope with 100 Newton. Rope will pull me with 100 Newton. So tension in the rope is 100 Newton. That is the restoring. So I took force on only one side of the dielectric. Divide by the area of cross section, I get the stress. Till here, there is no controversy at all. But trouble starts in the next problem because Irdov in the very first edition, Mir publications gave the wrong answer. HCV followed that wrong answer. Irdov rectified it in the third edition of his. Present editions of Irdov will give you the correct answer. What the question is, why they went wrong, will be explained. Take this down to here. This as it is picked up from the 4-author Russian book.
So we have to remember this.
Actually, you don't need to. I haven't come across a situation where you will directly use this, but if possible, remember it. Make a note of it in the notes. When you are revising once in a while, have a plan set. Maybe it will come to your rescue somewhere. 1 second. Wait.
Done, sir.
So remember, how do you define stress? How do you define stress?
Restoring force per unit area.
It is not force per unit area, it is restoring force per unit area of cross. Right? Now this is the problem asked by Redrawing. He himself asked the question. You people might not have done this maintenance. In two-tier cities, generally there will be power cut. So in home we have got inverter batteries, which will be connected to the fan and the light. Two fans and two lights at least will run when there is a power cut. Why? Even in the outskirts of Mumbai, Thane, Nerul, you have got power cuts during summer, right? Yes or no?
Yes, sir.
Yes, sir.
So, these inverter batteries are quite common in the two-tier cities or outskirts of Mumbai. Nowadays, you have got inverter batteries which are completely maintained. Our times, we used to once in a while pour distilled water inside the inverter battery and maintain the level of the water. Neither should it go up nor below, it should be at certain level. कार बैटरी कभी आप सर्विसिंग के लिए ले जाएंगे तो मैनोमीटर यूज करके देखता है above is red, below is orange, it should be green somewhere in between. पानी ज्यादा होने से भी दिक्कत होती है, कम होने से भी दिक्कत होता है. Distilled water, dielectric. Today you pour distilled water and you keep it on. When the capacitor gets charged, the distilled water will rise. So on the top corner of the inverter battery, there will be a small hole. Top corner of the inverter battery, there will be a small hole through which the water will seep out. Right? So level of the water will rise. Bottom line, this is what I'm trying to tell you. Irido asked you, what is the height? If the water level was like this, what is the height to which the water level will rise? The height to which water level rises. Height to which water level rises. This is the question asked by Irido. What HCV did to this? was this. He took the force from here, not the stress. Force on one side of the dielectric. This stress you calculated from what? By taking force on one side of the dielectric? Yes or no?
Yes, sir.
Force will be Q square A by, sorry, Q square by 2A epsilon naught epsilon r square minus 1 by epsilon r square. This is force on one side of the dielectric. He equated that to mg. Ah is the volume, rho into g. Q square by 2a square rho g epsilon naught epsilon r square minus 1 by epsilon r square. The very first edition of Redrawing and the present version of HCV gives you this answer. There are a few people who support HCV even now. Their argument is, what is wrong in taking force on one side of the liquid? You also calculated stress by taking force on one side of the liquid. We calculated stress. Stress is not force per unit area of cross section. For equilibrium condition, I cannot take force on one side of the liquid. I should take net force. For equilibrium condition, I should take net force. You cannot take force on one side of the liquid. यार तुम लोगों ने भी फोर्स ऑन वन साइड ऑफ द लिक्विड ले लिया ना यार भाई साहब हमने वहां स्ट्रेस कैलकुलेट किया है वो रिस्टोरिंग फोर्स है नॉट द नेट फोर्स यहाँ इफ यू वांट इक्विलिब्रियम कंडीशन यू शुड टेक नेट फोर्स जहां तक मैं जानता हूं नेट फोर्स जीरो जहां तक मैं जानता हूं नेट फोर्स जीरो है कौन सा फोर्स लिक्विड को ऊपर खींच रहा है भाई साहब I don't see any force. If you tell me net force, it is zero. So people stick to this particular solution. It's wrong for sure. Liquid का एक साइड का फोर्स आप ले लोगे और इक्विलिब्रियम कंडीशन बताओगे हो ही नहीं सकता. Next editions of Redrawing, he changed the answer. What did he do? If ever there is a controversy in stable equilibrium, what is the fundamental requirement for stable equilibrium? Potential energy should be minimum. What is the fundamental requirement for stable equilibrium? Potential energy should be minimum. That is the first definition. Do you agree with that or not?
Yes, sir.
Taking the force on one surface of the liquid and equating it to zero is not acceptable. Net force linear. And I don't think there is a net force, it is zero. Among all the forces that I see, they are all balancing out. Second, there is a normal force here on the liquid. You have to take that as well. Taking force on one side of the liquid and equate it to mg is not acceptable. Okay, now there is a controversy. Let me go from the fundamental concept. What is the fundamental concept? Potential energy should remain minimum. Potential energy is not just electrostatic potential energy, gravitation. Potential energy बोलते ही आप लोग बोलोगे, let this occupy whole of the space. Capacitance will reach maximum. Potential energy will be minimum. अगर ये whole of the space occupy कर रहा है तो gravitational potential energy is rising. Combination should be minimum. Combination should be minimum. So somewhere there will be a bridging gap between the two. Right? So if this is T1 and this is T2, this is T1 and this is T2, Q square by 1 by C1 plus 1 by C2. They both are in series. So 1 by C1 plus 1 by C2. AH rho GH by Q square by 2. C1 epsilon naught A by D minus H. Epsilon R epsilon naught A by H. A rho G H square by 2. Q square by 2A epsilon naught D minus H plus H by epsilon R A rho G H square by 2. My requirement is du by dH should be 0. Why? Why should du by dH be 0? Potential energy should be
Minimum.
minimum. When I differentiate this, Q square by 2A epsilon naught minus 1 plus 1 by epsilon R A rho G H. H square differentiation 2H2 and 2 will get cancelled. And what do I get H as? Q square by 2A square rho G epsilon naught epsilon R minus 1 by epsilon R is the present answer given by Redrawing in his presentations. Stable equilibrium. What is the fundamental requirement? Potential energy should be minimum. Net total potential energy, electrostatic plus gravitation. Force on one side of the liquid, not permitted. From what I can see, net force according to me is turning out to be 0. So which force is pulling the liquid above? I'm not aware of that. There is some other force playing in this particular game. In this problem, there is one more force which is playing, which I'm not aware of.
Liquid is acting as dipole.
So I didn't deal with the dynamic equation only. Because I am not aware of the force, you played it safe with potential energy. Present editions of Redrawing give you this answer. Hence is Redrawing. But our story is not at over. Agreed. You bought me the answer which Redrawing gave. Agreed. Potential energy should be minimum for stable equilibrium. Agreed. This should be the right way to come to the stable equilibrium. What is the force which pulled the liquid above? Not at answer. I got the solution of Redrawing. But why did I get the solution of Redrawing? Who is the force which is pulling it above? Need to be analyzed and understood, which will be done. Take it down till here. JE people are 100% aware of this. If ever JE people ask for the height to which the liquid level rises, you will go with this. Right? 1 second here.
Done, sir.
Now, the history of this, what is the force which pulls the liquid level above is because of fringing fields. That will take one complete hour to explain. I will send you the derivation part and the pic from Griffiths. Please have a look at it. I will re-explain whole of that in the next class. It will take me 1 hour to explain whole of that history. Griffiths answers it in a very subtle way, and you will be amused to see that logic given. Griffiths is the godfather for that concept. He writes, due to my ingenious method, लिखता है वो textbook में, due to my ingenious method, that explanation is not given in Halliday-Resnick or university physics or Irdo. Griffiths is the godfather for that topic. I'll send you a photo pic of this today. Read that paper and I will explain it in the next class. Homework, complete HCV and booklet capacitors. Is that clear?
Yes, sir.
When is the next lecture?
So Thursday.
Okay. I will send you the photocopy of that Griffiths derivation today. Try to read that before Thursday. Fine.
Yes, sir.
Sir, first HCV you will discuss.
Yeah, first HCV, then the booklet and the assignment sheet I sent to you.
So when's the doubt lecture?
Thursday, 1 hour I take to complete this, and thereafter I'll continue with doubts of capacity.
Okay, sir.
Sir, capacitors will be over then.
Yeah.
Thank you, sir.
See you people in the next class.
Thank you, sir.
Good day. Bye.